Have you ever thought about the sun as a massive nuclear furnace ceaselessly burning? That's right. Our sun, that familiar celestial body we see every day, is essentially a gigantic nuclear reactor, continuously undergoing a process called nuclear fusion. This is not your average fire, my friends. This is nuclear fusion, a process by which hydrogen atoms, under tremendous heat and pressure, combine to form helium atoms. But here's the kicker. This process doesn't just produce helium, it also releases a colossal amount of energy. This energy, in the form of light and heat, streams out from the sun, traverses the 93 million miles of space to reach our little blue planet we call Earth. And what would we be without this energy? Well, life as we know it wouldn't exist. You see, the sun's energy is the primary source of heat for our planet. It's what powers the water cycle, driving the rains and winds that shape our landscapes. It's what fuels photosynthesis, the process by which plants convert sunlight into chemical energy, providing the basis for virtually all life on Earth. But that's not all. The energy from the sun doesn't just stop at making life possible. It also provides us with renewable sources of energy, from solar panels soaking up the sun's rays to generate electricity, to wind turbines spinning in the breeze created by the sun's uneven heating of the Earth's surface. We are harnessing the sun's energy in a myriad of ways. So let's take a moment to appreciate this massive, blazing ball of gas. The sun, our sun, is more than just a bright light in the sky. It's an everlasting nuclear furnace, a powerhouse of energy that keeps our world turning. It's the lifeblood of our planet, a celestial dynamo that has been burning for about 4.5 billion years and will continue to burn for another 5 billion or so. In essence, the sun is a natural, self-sustaining nuclear reactor. Now, imagine humanity's most destructive invention, the nuclear weapon. Born out of the need for an upper hand in the theater of war, nuclear weapons have come to symbolize the devastating power humanity can wield. At the heart of these weapons is a process known as nuclear fission. Picture, if you will, a heavy atom like uranium or plutonium. When struck by a neutron, these atoms split into smaller atoms. This splitting or fission of atoms releases a tremendous amount of energy, enough to level entire cities. This process is not unlike the one taking place in the sun, where atoms combine or fuse together to release energy. However, instead of fusing atoms together like the sun, nuclear weapons split them apart. And the energy released? It's on a scale similar to the sun, but channeled in a devastatingly destructive manner. The world witnessed the destructive power of nuclear weapons in the summer of 1945. The cities of Hiroshima and Nagasaki in Japan were subject to this destructive force, resulting in the loss of hundreds of thousands of lives. The aftermath was equally horrifying. Those who survived the initial impact suffered from radiation sickness, burns, and the mental trauma of having witnessed such a calamity. Such is the power of nuclear weapons, a power that humanity wields with a heavy responsibility. These weapons are not just symbols of military might, but also reminders of the devastation they can cause. They serve as a testament to human ingenuity, a perverse example of our ability to harness the fundamental forces of nature, not for creation, but for destruction. Nuclear weapons, therefore, are man-made devices capable of releasing energy on a scale similar to the sun, but in a destructive manner. The sun gives life, while nuclear weapons, when used, bring only death and destruction. The contrast couldn't be starker. As we continue our exploration of what would happen if we were to nuke the sun, let's keep this in mind. What would happen if we were to launch a nuclear weapon into the sun? Ah, the realm of hypotheticals, a place where our curiosity runs wild. Let's explore this scenario, shall we? In theory, if we were to somehow manage to hurl a nuclear weapon into the sun, what would happen? Well, first things first, we need to understand the nature of the sun itself. It's not a solid ball of rock like Earth, rather, it's a giant glowing ball of hot plasma, with temperatures reaching millions of degrees at its core. That's hotter than any nuclear bomb we've ever created. Now imagine our nuclear weapon blazing through the cosmos, on a collision course with this fiery celestial body. As our nuclear missile draws closer, it is greeted by an increasingly hostile environment. The sun's intense heat starts to take its toll, and the weapon begins to vaporize long before it ever reaches the sun's core. The metals, the electronics, the nuclear material itself, everything would be reduced to its basic atomic components. But let's say, against all odds, our nuclear weapon somehow survives the journey and reaches the sun's core. What then? Well, the sun is essentially a natural nuclear reactor, constantly undergoing nuclear fusion. This process is millions of times more powerful than any nuclear weapon we can produce. So even if our nuclear bomb were to detonate at the sun's core, it would be like throwing a pebble into the ocean. The sun wouldn't even notice. So after all the effort, all the resources spent, and all the risks taken, the end result would be a whole lot of nothing. Our nuclear weapon, once a symbol of humanity's destructive power, would be reduced to a mere puff of plasma, swallowed up by the sun's immense energy. Hence, it's safe to say that nuking the sun would be a futile endeavor. It's an interesting thought experiment, but in reality it's a mission with no real reward, and a whole lot of potential risks. But let's delve deeper into the aftermath of such a scenario. The first thing to consider is that our hypothetical nuclear bomb, however powerful, would likely be dwarfed by the sun's own immense energy. This doesn't mean, however, that it would go unnoticed. The energy released by the bomb could potentially trigger a solar flare or a coronal mass ejection. What are these, you ask? Well, they're basically huge eruptions of energy on the sun's surface, and they can have significant effects right here on Earth. Solar flares and coronal mass ejections can send a wave of charged particles hurtling towards Earth. When these particles interact with our planet's magnetic field, they can cause geomagnetic storms. These storms can have a range of effects, from creating beautiful auroras to potentially disrupting electronic systems. If a particularly strong storm were to hit Earth, it could knock out power grids, disrupt satellite communications, and even affect the navigation systems on which we all so heavily rely. But this isn't just about the physical consequences. There are also ethical implications to consider. The sun, after all, isn't just our own private energy source, it belongs to all the life forms in our solar system. Taking such a drastic action could have unforeseen consequences, not just for us, but for any potential life elsewhere in the solar system. And let's not forget the psychological impact. The knowledge that we had tried to nuke the sun, that we had attempted to tamper with the very source of our life-giving energy, could have a profound effect on the human psyche. It could make us question our place in the universe, our responsibility as a species, and our ability to control our own destructive impulses. So while our hypothetical bomb might not blow up the sun, it could still have far-reaching consequences. It could disrupt our technology, challenge our ethics, and shake our understanding of ourselves. While the sun would remain largely unaffected, the consequences on Earth could be far-reaching. So what does this exercise in speculative science teach us? Firstly, it underscores the scale of the sun's nuclear reactions, a scale far beyond human capabilities. The sun, a seemingly endless nuclear furnace, operates on a level of power that dwarfs our deadliest creations. It churns out energy at a rate equivalent to 1 billion megaton nuclear bombs every second. That's 1 billion times the strength of the largest nuclear weapon ever detonated on Earth, every single second. This thought experiment also highlights the limitations of our power. Despite the destruction we can wreak on our own planet, in the wider cosmos, we are insignificant. The sun wouldn't even notice if we hurled our entire nuclear arsenal into its fiery maw. Instead, it would continue to burn, unabated and unbothered, providing light and life to our world as it has for billions of years. But perhaps the most important lesson to draw from this is the importance of humility. We humans have a tendency to overestimate our importance in the grand scheme of things. We build towering skyscrapers, split atoms, and even leave our footprints on the moon. Yet, when faced with the colossal forces of nature, we are but a speck in the cosmic sea. This realization should not discourage us, but rather inspire respect and responsibility. We are the caretakers of Earth, our only home. We wield the power to both create and destroy, and with this power comes immense responsibility. We must use our scientific knowledge wisely, not to wage wars or wreak havoc, but to better understand our place in the cosmos, to protect our planet, and to ensure the survival and prosperity of future generations. In the grand scheme of the universe, our most destructive weapons are but a speck of dust before the immense power of the sun. And that, my friends, is a lesson in humility.